So let's see if we can't divide these out, basically. We're going to use long division. It's long division is what this is. So if the y minus 1's on the bottom, that's what you're dividing by, right? You're dividing by y minus 1. So you see how it goes 7y squared? There's no other y value in there, and then it just goes straight to. I'm going to put me a 0y in here just as a placeholder, because I'm going to do long division, and we have to make sure we combine like terms. So I need placeholders basically. Okay. So I need to figure out, how do I turn y? This is how you start basically. How do you turn y into 7y squared? You multiply this by 7y. So 7y times y is 7y squared. And 7y times a negative 1 is negative 7y. That's why I needed that placeholder, because I have to combine like terms there. Now what you going to do? Well, first I'm going to subtract these off. If it's long division, remember how you subtract how long division, you subtract this step right here. So I'm going to subtract now, but I'm subtracting both of them. So basically what that does, it changes those signs. So I like to just change them and act like I'm adding. That's what I like to do. You can do it however you want to do it. But that's going to turn that into a 7y, a positive 7y. 0 plus 7. Well, this has two terms in it. My divisor has two terms. So really this needs two terms. So we're just going to bring this down. That's legal. We can just bring it down. Remember how in long division you can just bring stuff down? So now you don't worry about this top stuff anymore. You worry about this first term. How do you turn a y into a 7y? You times it by 7. A positive 7? So I say plus 7. 7 times y is a 7y. 7 times a negative 1 is a negative 7. So I'm subtracting it though, right? So that changes all my signs. So those cancel like they're supposed to. Negative 2 plus 7. That's a 5, isn't it? Okay, so that's your remainder. You ask yourself, can you turn a y into a 5 without a y? You can't take away y's with multiplication. You just can't. So we're done. That's our remainder. So when we write our answer here, 7y plus 7 plus our remainder of 5 divided by y minus 1. So you have to write your remainder there. Does that make sense with the remainder?
Yeah, it's just like you're dividing, still dividing.
Yeah, it's like you're still dividing it. And yeah, you're dividing it, but you can't go any farther. So that's just your little fraction. It's just like in long division. You're supposed to put your plus your remainder like that. So the next one is x plus 1 going into x cubed plus 4x plus 5. Now do you see how it goes x cubed and then 4x plus 5? You see how it jumped over x squared, didn't it? So I need to put a placeholder in there. Put me a 0x. That's just a placeholder. 0 times anything is 0. That's right. If it skips, I might not even need it, but it's better that it's there to begin with than to have to go back and fool with things. Okay, so I always, like you said, if it skips something, I always put a 0 something there for a placeholder. So the first thing you do is you compare the front terms. How do you turn in x into x cubed? Times it by x squared. That's right. So that's an x cubed. That's a plus 1x squared. So I'm glad I had that 0x squared there, because that's lining up. It's real easy to screw up if you don't have things line up. So I'm subtracting it though. That's what you're supposed to do. So I'm going to change my signs and act like I'm adding.
So you do the x squared times that and then x squared times 1?
Yeah, I'm multiplying this times, I'm distributing to both of these. Yep. And you know what? This guy's got 2 terms in it. So this guy down here is going to need 2 terms. So I'm going to go ahead and bring the 4x down. I might even have to bring the 5 down sometimes, but we're just going to leave it. We'll leave it there. We'll bring it down if we need it. So now you're going to compare this guy with, I'm never going to go back up here and compare anymore. I'm not going to do that anymore. I'm just going to compare it down here. So x turn into a negative x squared. I got a negative, but I also need an x, another x, don't I? So negative 1x. Can I just write negative x instead of negative 1x? Okay. So that would be a negative x squared minus x. You doing all right?
Mm-hmm.
Okay.
I worked this myself. I just missed one thing.
Man, these stink about missing one sign. Man, if you miss this one sign here, you're dead. Yeah, as Mark said, you're dead. I mean, you're just dead because everything's going to be off. Because you're going to screw this up, which is going to screw that up, which will screw this up, which screws the next one up, and on and on and on. So if I ever think I've messed up, I would just start all over again.
I think when I went to multiply that x times 1, I didn't carry my negative sign.
This guy right here, this times this. Okay. And plus, the other,
I changed it to minus.
yeah, because the other thing about going back and looking at your work here is you're going to be changing so many signs that I just can't follow it. I just do it piece by piece, and if I screw up, I'll start all over again.
Probably wouldn't hurt to do it again.
To check your work, it probably wouldn't hurt to do it again, would it?
Switching the signs. She leaves it the way it's supposed to be, then in parentheses above, where the sign you're going to change it there, and that way you can see what they're doing.
You can write it. You can write it again. Yeah, you could write it down one more time. So now you got x and a 5x. How would you turn x into 5x? 5? Positive 5, right? So a 5x plus 5. Well, these are the same, right? So if I subtract them, I'm going to get a remainder of nothing. X squared minus x plus 5 is my answer. Now check it out. If you want to check your work, you can take x plus 1 times what I've circled here, your answer. It should give you what's under that box. So you could, without doing it all over again, you could multiply it all back out and see if it would work. So that'd be one way, like on a test, to make sure you've done it right, instead of redoing the whole thing over again. Because here's what I would do. I would do it one way, and then I did it again, I get something different. Like, oh crap, I screwed up. And then I do it again, and I get another something different. So I'll be like 3 times I've done something different all 3 times. So, and the first time was right anyways. So that would be my luck. So I would multiply this out to begin with to see if I got this right. That's what I would do. Right. So let's try one more. So this one has a 2x cubed plus 3x squared plus 4x minus 36. Let me show you a trick. Did you see how number 1, 2, and 3, the bottom is just y minus 1, x plus 1, x minus 2? See, it's just a binomial. There's nothing in front of x. Just this over here. You can use a thing called synthetic division. So like this over here. Let me show you a trick here. It's called synthetic division. So just hang with me for a second. Basically, I can do all this right here, what I just did, without all the x's. I'm going to do all this right here without the x's. So I'm going to take the 1, but I'm going to make that a negative 1. The trick is you always change that little sign right there. And then I'm going to use a 1, a 0, a 4, and a 5. This is called synthetic division. Do what? Basically, I'm going to start. Remember how you always start with this one? You always start to compare this, right? So I'm going to bring this down. I'm going to multiply. What's 1 times negative 1? Okay, and then I'm going to add. So I start off with x cubed, so I end up with x squared minus 1x plus 5, with 0 being my remainder. X squared minus x plus 5. That doesn't break your heart, does it?
It breaks my heart, you didn't tell us that a long time ago.
So like if I wanted to use synthetic division on this, and it only works for these kind of guys, so I'd use a 2, a 3, a 4, and a negative 36. And I'm gonna, instead of negative 2 though, I'm going to use a positive 2. I always flip that sign right there. So you bring this down. The first one you just bring down. So what would I write right here? A 4, and then here 7. I'm just combining these together. So I multiply off this box, and then I add down. I bring the 2 down, multiply it by 2, and put it on the 3. So now the next number I put here, 2 times 7, 14. So now I add this, and 2 times 18, 36. You add this, 0. I started off with x cubed, right? So I'm going to end up with x squared. You always take one power away. So 2x squared plus 7x plus 18. And then 0 is my remainder.
If that had been negative 2, we'd have been going 3 minus 4. Minus 4.
3 minus 4 is negative 1. And then negative 2 times a negative 1 gives you that.
So you don't actually subtract like you do in these long divisions.
The reason why I don't subtract is because I changed that sign at the beginning.
That way you don't have to worry about making all those signs, right?
It's a little bit easier. But it only works, you know, like on that very first one that we did. Yeah, and you got, if you don't put those zeros in, it screws everything up too. But like this very first one we did, I'm going to use a 1 because, I mean, you're subtracting every time you do this, right? The long division. So I'm going to use a positive 1 to kind of compensate for that. And a 7, a 0, and a negative 2. So I'm going to bring the 7 down, multiply. So what do I write here? 7. I add, multiply, add, 5. So I start off with y squared. So what do I wind up with? Nope. You always take 1 away. So it's 7y plus 7 plus 5 over y minus 1. Right? This is my remainder right here. Synthetic division. We're going to use that 150. So if you don't feel like you're just, I mean, there's a section in here that's this synthetic division section in Hawks. It wouldn't be that bad of an idea to go through it and hit it up if you had extra time. If you didn't have extra time, because we're going to use both. We're going to use long division and synthetic. So, but you could do that with 1, 2, and 3.
Yeah, you